Hey, how's it going, everybody? Victor here, and tonight we'll do a introduction to MPLS. More specifically, we'll be setting up RSVP, or the Resource Reservation Protocol. But before anything, let's take a look at the topology that we have here. So this is a multi-vendor topology. We are running JunOS, some IOSXR, and then IOSXR. As you can see, we have a core. So this is a service provider topology scenario. So we have a core with 4 routers, and then we have hub 1 and hub 2, which is where the provider edge routers would be. So let's take a look here. And so far, all that I've done is that I enable OSPF throughout the core, and as you can see, all the OSPF adjacencies are in full state. And the other thing that I did is that I went ahead and set the MTU on the interfaces to 2000 for the physical MTU, and then 1800 for the IPv4 MTU. That way we don't really need to worry about the multiple headers that we're going to be adding as we add more services to this topology here. So MPLS is a 4-byte header that we add to the IPv4 packet. So that will be 32 bits. There are two, and this is kind of confusing because there are 2 label distribution protocols, and one of them is called LDP. But again, this is a label distribution protocol, just as RSVP. But it's worth mentioning that RSVP was actually created for host-to-host quality of service communication. So basically, originally was a QoS protocol for host-to-host communication. It was then adapted to service providers so that the service providers are able to run RSVP throughout their cores to set up dynamic LSPs or label switch paths, and not just dynamically, but you can also explicitly say the path that's given LSP has to take, and that's where all traffic engineering comes in, and the fact that you're also able to set up different paths depending on the amount of resources that you have per links. So that's what RSVP is all about. So when it comes to MPLS labels, we have, and I'm sure you've heard of this, about the penultimate hub. So if basically we're setting up an LSP or a path between XRV5 and XE7, the XRV2, assuming the ingress router would be XRV5, XRV2 would be popping the label out before forwarding the packet to XE7. That's called the implicit null, which means that XE7 is going to signal XRV2 telling, hey, before you send me anything, make sure you pop out the label, because I'm going to then, as I receive it, I'm going to then route it based on my inet.0 table. If it was a JunOS, in this case, I'll just do a show route, and then I'll show a P route, and then I'll figure out where I need to send it to based on that output that I have there. So, like I said, we took care of the MTUs by show config interfaces, by changing the MTU on all the interfaces, and so the next step that we're going to take is that I'll go ahead and enable MPLS and RSVP on all the interfaces in this topology. So I'll do it for, say, VMX1, XRV2, and XE7 to cover the 3 different platforms, 3 different operating systems. And then I'm going to pause the video and resume when I'm done with all the other routers. Okay? Save us some time. Alright, so starting with VMX1, so we'll jump in here. Oops, drop down to the edit. And let's go. Show me the interfaces and do set interface 000.0 family MPLS, and we gotta do the same for G2 and G1. Then we'll also go to set protocols, RSVP, and interface. I think we can do all. Yes. And set protocols, MPLS, interface, all. And then let's go to the protocols OSPF and set traffic engineering. And that should take care of that. Let's just double check here. What do we have? And oh, we haven't committed. Alright, that looks good. Let's now jump over to XRV2. Oops. And alright, so basically the same thing. We gotta enable traffic engineering in the OSPF process. So we'll go to config and router OSPF1, address family, IP4 unicast, area 0, and MPLS traffic engineering. And exit out of here. Oops, I think I forgot about. Maybe. Okay. RSVP interface. Gotta do individually. And that should take care of that. Now it's also the MPLS traffic engineering and the interfaces as well. And I think that should do it. Let's take a look here. Click commit. Run. MPLS traffic engineering. Okay, that looks good. Alright, so now going to CXR 7 or XE7. It's basically the same thing. It's just that we gotta enable this globally. MPLS traffic engineering tunnels, and then we just gotta enable under the two interfaces. So gig 1 is MPLS traffic engineering tunnels, and gig 3 MPLS traffic engineering tunnels, and that should take care of this. Or MPLS traffic engineering area 0 and traffic engineering router ID look like 0. Okay? And before I forget, we'll do a copy run start. Alright, so now I'll go ahead and pause and do the same on the routers that are left over. So it will be XRV 3, 4, 8, 6, and 5. I'll be right back. Alright, so now RSVP should be enabled on all the interfaces here connecting the core and the hub 1 and 2 on all the routers. And I think I forgot to mention on XE7 here, you also gotta enable MPLS IP under the interface and a under global config as well. I think I forgot to say that, or forgot to do it when I was setting up XE7. So, alright, so now if we were to go to, say, VMX6 and do a run show RSVP interfaces, we can see that we have RSVP enabled on both gigabit 000 and 002. And same here on XRV5, if we were to do show as RSVP interfaces, we can see pretty much the same output. Alright, so like I said, the normal behavior or the default behavior is that the egress router and the LSPs, and when it comes to RSVP, the LSPs are unidirectional. So that means that we would need to have an LSP going from XRV5 to XE7, and then another LSP going from XE7 to XRV5. And what I was saying is that the default behavior is that implicit null, that the egress router is going to signal the penultimate router so that it will pop out the label before forwarding the packet. Now, on Juniper, there's a particular behavior in that is that we have multiple routing tables. So, for instance, if we were to go to VMX6 and do run show route, as you can see, what it's showing you here is the inet.0 table, which is the one that will hold the IPv4 unicast route table. There's also the MPLS.0 table, which pretty much holds the label to forwarding equivalence, or the FEC, along an LSP. And so this is handled by the LDP protocol. So in this case, it will be RSVP. This MPLS.0 table is the one that, for instance, if we were to have an LSP between VMX6 and VMX8, then VMX4 would consult this MPLS0 table to find out what label to push or pop, or whatever operation you need to do in order to keep forwarding the packet to the egress destination. So there's also a route table called inet.3, which is the one that by default BGP is going to look into this table and figure out what LSP to use in order to forward a packet. So that means that the inet.3 table is actually used by the ingress router. As the packets come in, it's got to figure out what RSB, or what LSP to use to forward that traffic. And so, if you really want to know more about RSVP, I suggest you go and take a look at the RFCs. We basically have RFC 2205 and RFC 3209. And 3209 is the actual traffic engineering one, or the extended RSVP. And so, alright, so back to the main topic, and that is the operation of RSVP. Fundamentally, we have two different. Pretty much all the protocol is handled by this objects within the header. So the two most fundamental objects are the path and RESV messages. So the path message is the one that the ingress router would send across the LSP to the egress router to signal the establishment of the LSP. Basically says, hey, I need this LSP to be created. And then there's also the RESV message, or the RESV message, reservation message, that is the other way around. It's sent from the egress all the way back to the ingress router, which pretty much says whatever amount of reservation the path needs to accommodate. So let's now that we have this set up, let's take a look at the most basic implementation of an RSVP. I mean, an LSP, RSVP signal LSP. So we'll set up an LSP between VMX6 and VMX8, and we'll do that by simply going to VMX6, and we're already here. And excuse me, we'll do set protocols MPLS, and then label switch path. We're gonna name it whatever we want. So this one will be on VMX6 to VMX8, or from router 6 to router 8. Oops. And we're gonna say that the 2, which is the egress router address, is gonna be 8.8.8.8. Okay, and this is pretty much it, because we're not gonna do an explicit route object or ERO, which is the explicit path, or basically telling the path which direction to take. For instance, you might want to tell the LSP to traverse XRV3 and then go to 1 and then go to 2 and then go to 7 and then go to 8. In this case, we're not doing that. So if we now were to look at route, or even better, table inet.3, we can see that now we have an LSP, which is an RSVP route to get to 8.8.8.8, but like I said, by default, the only protocol that really recurses to this inet.3 table is the BGP protocol. In this case, we haven't even set BGP up, and we'll do that in the future, but not for now. So one way around this would be to go to protocols MPLS, and inside the label switch path that we have, which is front, and you can see this really cool. It puts it right there for you to just tab through it. And then there's an option here called install prefix, and the prefix that we want to install is 8.8.8/32 active, because we want to install it into the forwarding table. Oops. So now, if we were to do show route, we should have an 8.8.8.8 route here, which should be an RSVP route. Which is still this one here. So actually, and I forgot to do this. So if we were to ping to 8.8.8.8 now, we would be using. Oh, I'm sorry. Let's do a trace route. This is what I meant. Alright, so excuse me. Let's go a step back because I forgot to show you one crucial thing before. So let's take a look at what we have here, which is under MPLS. We have our label switch path called from R6 to R8, and we have installed this LSP into the inet.0 table, or basically told the box to, hey, just use this LSP in order to get to 8.8.8.8, no matter that we don't have BGP enabled here. So before we do this, let me delete that real quick so I can show you the difference here. Okay, and if I were to do a trace route to 8.8.8, as you can see, we're not using the LSP, despite the fact that we have it in the inet.3 table. So if we were to put this back on and do a commit and do a trace route to 8.8.8, now we're using the LSP. Good. Alright, so like I said, this is a unidirectional LSP, so we would need to have a return path or a return LSP from VMX8 to VMX6, but we're not even going to bother with that right now. Let's go ahead and try to create an explicit path, and so another LSP explicitly defined between XRV5 and XE7. So for this, we'll go to XRV5. And first, let's go ahead and go to the explicit path configuration mode, and or I should say configuration hierarchy, and let's name it from R5 to R7. Okay, and in this case, we're gonna add indexes. So our first index is gonna be a next hop, or next address, I should say. It's going to be a strict because we want it to go to this one next. So you basically have loose and strict. Loose, what loose means is that I could say loose, I don't know, 3.3.3.3, and what that means is that the LSP has to, and assuming this is the remote end, or the egress would be 7. Before it gets to 7, it somehow has to pass through level router 3. That's what loose means. It doesn't say that, hey, you need to go to that next address right now. It just says that, hey, before you get to the end, make sure you pass by the router 3. But in this case, we'll just do a strict and 1.1.1. Or strict IPv4 unicast 1.1.1.1. Now we're going to add another index, next address, and let's make it go the long way. So strict IPv4 unicast 3.3.3 and 4.4.4.4 for index 3. Then go to 8. And finally, or you know what, we don't need to, because we're going to terminate it at router 7, so we don't need to specify that last hop or last address. Alright, so now, and this is where things get a little different between JunOS and IOSXR and IOSXC, is that we need to create a tunnel interface, a tunnel traffic engineering interface. So for that, we'll go to interface, tunnel, TE, we're gonna name it 57 since we're going from 5 to 7. And we're gonna say IPv4 unnumbered, loopback 0, and the destination is gonna be router 7. And here's where we say what LSP to take. So it's called path option, primary or fallback path setup option. So our path option is gonna be the preference, let's just say 1, and explicit, and the name is whatever name we set here, I don't even remember, from R5 to R7, and this should take care of this. Okay, do a commit. Alright, so if we now were to go to show RSVP, and is it routes or F5? No, this is not what I meant. Show MPLS. Traffic engineering, tunnels. Alright, excuse me. So here's the tunnel that we have. As you can see, it's operationally down, and the destination is 7.7.7.7. Signaling is down. So we'll try to bring this up now. So we basically have two choices. We can either signal or route this tunnel using a static route, or we also have this option which works similarly to the install statement that we did on JunOS. So, but for now, let's go ahead and create a static route. So router static and address IPv4 unicast, and we'll do the destination, which is 7.7.7/32, and we're gonna say that the next egress interface is the tunnel traffic engineering interface, which was 57, right? And do a commit. And you know what? I keep forgetting this. So if we now do the trace. So that works, and no, excuse me. So yeah, this is not working. As you can see, we're not actually using the explicit path that we defined. So let's take a look at what's going on here. Show run router static. So we have that, and show interface tunnel, or sorry, show run interface tunnel, TE57. Show interface brief. Is this what I'm? Oh, okay. Interface tunnel TE57. Do I need to? IPv4 number, look back, destinations there. Alright, so see what's going on here. no path destination 7.7.7.7. So path is not valid, signaling down. So that means there's something wrong along the way. All right, so make sure that we do have a route to 7.7, and we should do, because we were able to trace route to it. So we do. That means what this means that the RSVP adjacency is broken somewhere along the way. So let's go ahead and make sure that we have RSVP enabled on all the interfaces connecting to this. So I'm sorry. So from 5 we were going to 1. On show RSVP interfaces. Okay. Then we were going to 3. Then we were going to 4. And to 8. And then on 7. I wonder if it was because this was locked out. Show RSVP or show MPLS traffic engineering interface or MPLS interfaces. Tunnel, yes. So that means it's up. Let's take a look here. Explicit path. So from 1 to 3 to 4 to 8. I wonder if we need to terminate it. Let's see. This would be different than JunOS if that's the case. We're just gonna add a next address strict IP40 unicast of 7.7.7.7 and do it commit. Let's see what happens now. Oh, okay. So now it's up. So we needed to add the very last hop, or the termination of the tunnel of the LSP, despite the fact that despite the fact that we set that up here in destination on the tunnel interface. But that's okay. It's slightly different from JunOS. So if we were to, and do we still have the route? Static, we do. So if we were to trace to 7.7.7, we should be able to see the LSP being used. And we can. So as you can see, it now goes from router 1 to 3 to 4 to 8 and finally to 7. So that's pretty much what RSVP is all about. I'm not going to show the config here on XE7. You can just Google that. It's very straightforward. Very similar to an IOSXR. So for now, I think I'll leave this video to this point. We are 34 minutes into it so far at the moment. So the next step would be to, I'm thinking we're gonna clear all this RSVP config and go back to LDP or regular, the most common LDP, because then what we will do is turn on these different customers that we have here. This red, purple, and yellow balls are gonna be customers, and we're gonna do different different schemes for that. So, like for instance, one's going to be a point-to-point, the other one's going to be a VPLS, the other one's going to be a layer 3 VPN, and we're also going to enable BGP throughout the core. We're going to set up some MPBGP and some address families between the P's, between hub 1 and hub 2, and I guess later we'll see what else we can do. For now, I hope this has been informative for you, and I'd like to thank you for viewing. Please subscribe to my channel if you like this video. I do appreciate all the support that you guys give me, and your comments. Feel free to drop any comments down there. I appreciate the subscriptions that I've been getting lately. Thank you guys, and again, thanks for watching.